Welcome to this course on game theory. I'm dropping videos all semester as I teach the course. My name's Matt Rosu, professor of economics at Susquehanna University. Today we're going through a problem to examine how to solve a voting game. So this is a problem actually from an old test that I gave, and let's go to it. So in this particular problem, we're going to examine an election on a faculty campus, saying that the faculty are being asked to choose the next president for a university, which generally doesn't happen, but you'll have to bear with us on this. There are three candidates within the election: Doug, Cynthia, and Charlie, with four parties: business, social sciences, humanities, and arts. Their preferences and votes are given as follows, right? Each faction has a particular candidate they like best, second best, third best, or least, and each faction has some number of votes that they can give. So in this particular example, business prefers Cynthia. We see that social sciences top choice is Charlie. Humanities top choice is Cynthia, and the arts, it's Doug. So the first question: who would win if there's one vote and whoever received a plurality of the votes wins this election? Well, who are the number ones? Cynthia and Doug are number one with business and humanities. That's 45 of the votes. There are 50 other votes, but they'd be split among Doug and Charlie, because the arts would vote for Doug, social sciences vote for Charlie. So Cynthia would win this particular election if everybody voted naively, as we say. So I talked about in a previous video, it might sound derogatory in there, but it's not meant to. It's just everybody's voting for the person they think would do best. Is there a Condorcet candidate? If so, who? If not, why or why not? So a Condorcet candidate is a candidate who would defeat all the other candidates in a heads-up election. So if you match up one-on-one, is there somebody who wins all of the one-on-one matchups? So we have to dig into this a little bit. We'll start by looking at Cynthia versus Doug. So we're going to be looking at Cynthia versus Doug. Cynthia is the top choice of the business and humanities. That would be 45 votes. Doug is top choice among the arts. That's 20 votes. But then Doug's preferred by social sciences, which is an additional 30 votes. So Doug would have 50 votes, and Cynthia would have 45. In a one-on-one matchup, Doug would defeat Cynthia. Okay, what about Cynthia versus Charlie? Who would win that one-on-one matchup? Well, if it's Cynthia versus Charlie, we see Cynthia is the top choice among business and humanities. Charlie's the top choice among social sciences, and Cynthia is the preferred choice, the second choice, over Charlie among the arts, who have Charlie as the least favorite candidate. So here we would see that Cynthia would get a total of 65 votes, 25 from business and the additional 40 from humanities and arts. Charlie gets 30. So 65 to 30. Cynthia would defeat Charlie in a one-on-one matchup. Finally, we look at Doug versus Charlie. Doug is the top choice among the arts. Charlie is the top choice among the social sciences. Doug is preferred by the humanities for 20 votes. Charlie is preferred by business for 25 votes. So Charlie gets 55 votes. Doug gets 40 votes. Charlie would win. So notice what we saw here. We saw Doug beat Cynthia, Cynthia beat Charlie, Charlie beat Doug. Nobody wins all the one-on-one matchups. So there is not a Condorcet candidate. The next part of this problem, and in a previous video, I mentioned how the voting schemes can often matter. Suppose the rules of the election dictate that after the initial round of voting, if there is no majority, there's a runoff election. Top two candidates, the majority wins. If everybody voted naively, who would win in this particular election? First, one thing that we remember is if it gets into a runoff, we know who wins each runoff because we know how the votes went when Cynthia versus Doug, Cynthia versus Charlie, and Doug versus Charlie. So that part helps us out. This next part's easy. We just have to see what happens in the initial round. Well, if everybody's voting for their first candidate, Cynthia is going to get 45 votes, Charlie's going to get 30 votes, and Doug is going to get 20 votes. Nobody gets a majority because there are a total of 95 votes. The highest is 45. That's less than half. So Cynthia goes to the runoff with the highest total of 45 votes. Charlie also goes to the runoff with the second highest total of 30 votes. And then what we saw before in a one-on-one matchup, Cynthia versus Charlie, Cynthia wins. So Cynthia would win in a runoff election format if everybody voted naively. The final question on this problem, are there any gains to voting strategically? These are the ones that are fun to think about. To gain from voting strategically, you vote different from what you'd vote in your naive vote in order to get a better outcome. Initially, of course, business and humanities get their number one choice of Cynthia. So who might have a benefit of changing? Well, let's look at the social sciences, right? They're getting their third best choice initially. It's not very ideal here for them. So is there anything they can do to maybe move, instead of getting Charlie, could they move to perhaps get Doug? Well, if they talked to the arts and said, you know what, we're just going to go ahead and back Doug because we'd rather get our second choice than our first choice, Doug would get 50 votes right away, right? Doug gets 30 from social sciences, 20 from the arts. That's 50 votes. That's a majority. Doug wins. Both the social sciences and the arts are happier based on that essentially coalition, right? That forms to put in the person that they prefer. Business and humanities aren't as happy, but they're in the minority. They can't do much about it. Is there anything any of the other parties could do then? Well, for humanities, it's their second best choice, but for business now, all of a sudden, Doug is the third best choice. So could they perhaps go to the social sciences and say, well, wait a second here. We would rather go to Charlie, who's our second best choice, and Charlie's your first choice. Why don't we all vote for Charlie? And then that would be 55 votes, and Charlie wins. And that makes sense, right? So Doug winning isn't an equilibrium because both business and social sciences would want to change. Is there anything that could be done at that point to change the election? Well, the humanities and the arts both do not like having Charlie in there. It's the least favorite person, right? Business is with their second preferred candidate. If both humanities and arts went to business and said, hey, why don't we all vote for Cynthia together? Every business and humanities and arts are all better off. So actually, they would all want to vote for Cynthia. But with Cynthia winning, we run back to the same situation as before. So this is a weird spot where there's actually no equilibrium in this voting game problem. There is no stable point. No matter who wins, there would be coalitions that could form, and you would see people wanting to change the choices. So interesting game with literally no equilibrium outcome in pure strategies for this voting game. Hope you found this game fascinating. Once again, my name's Matt Rosu, teaching game theory this semester. And if you liked this video, please click like and subscribe. It does help me out. And I look forward to seeing you in the next video.